It is not necessary that the shape should be regular or the size should be proper. Nothing. Any surface, okay, regardless of its shape and size. But for our convenience, we are using spherical and cylindrical. But Gauss law is holding good for all these things. Clear? It is, does not depend upon any shape and surface, you can see. Gaussian surface, yesterday itself we have seen. Okay. And Gauss law, what is that? We will write GL so that it will save. The Gauss law, the equation given is what? Q by, the phi is given by Q by epsilon naught, holds good for vacuum or air. Okay. When the charge is when the Q is located in any other media, like mica, glass, oil, plastic, what will happen? It needs to be modified. Okay, Gauss law needs to be modified according to the given condition. You are not going to learn, but you should know that. Okay, should be modified. Gauss law can be modified and used. You cannot use it directly. This is applicable only for the vacuum or air. I hope this point is clear. Any doubt, you can stop me. Anything?
Ma'am, why doesn't go?
Gauss law can apply the derivative. Any discrete charges. Discrete means separate charges. If you have Q plus Q3, Q, 5Q, when you consider a Gaussian surface, this Gaussian surface should not pass through this. It should include this charge. It should not pass through the charge. How you should draw? You should include all the charges and you have to draw. Is that clear? It should not cut the charges. The surface should not. It is an imaginary surface, right? This imaginary surface should not pass through the discrete charge. Whereas, remember this, but however, Gaussian surface can pass through continuous charge distribution. What does it mean? Plain sheet of charge. Okay, you just take one plain sheet, charged plain sheet. Okay, continuous charge distribution. Right, this one is okay. What is that? Sigma. Sigma is the, what is sigma? Linear charge, surface charge density, volume charge density. You should learn and come. So sigma is surface charge density, that is Q by area. So this is a continuous charge distribution. Here when you consider a Gaussian surface, you can consider one cylinder, imaginary cylinder, which can pass through this sheet. Now you have considered an imaginary cylinder which is passing through the sheet, right? It is cutting. You are not taking the entire sheet. You are taking a portion of sheet. So this is applicable. For continuous distribution, the Gaussian surface can pass through it. But for discrete charge, separate charge, you cannot draw inverse square root. What is it? Coulomb's law, gravitational law, gravitational forces also, Coulomb forces I should write. Gravitational forces, Coulomb forces. Because I have written forces, right? So both the cases you can apply Gauss law. It is not necessarily that you should apply only for Coulomb forces. Gauss law is even for gravitational forces. So that's what it means. Okay? Is that clear, ma'am?
Yes, ma'am.
So from the Gauss law, already we have learned electric flux. From the Gauss law, what is net flux now? Net flux is given by phi equal to, that is Q by epsilon naught. Otherwise, it is closed surface integral of, this is surface integral we say. Because we are doing the integration over, not line integral is also the surface integral. But generally, the circle will be nothing but what? Closed integral. Okay? Here we are doing it with respect to surface, so we are calling it a surface integral. But that is not our concern now. The net flux is given by Q by epsilon naught. If Q is positive. If Q is positive. What does it mean now? On the Gauss law, if you find net flux and if you are getting, if the Q given Q is positive, then the net flux is what? Outward. If Q is negative, the net flux will be inward. There are no. Already you know that flux also you have learned, electric field lines also you have learned. Electric flux is nothing but number of field lines only. And the next one is what? The net electric flux. I am not talking about simple electric flux, the net electric flux over a closed surface is independent of what? The first and foremost, as we discussed earlier, the nature of shape or size of space enclosed by Gaussian surface. Simply what I can write? It is independent of Gaussian surface. You take cylindrical, you take spherical, you imagine some planar, anything is fine. I have no issues. It does not depend on this shape. Then pattern of distribution. Pattern of charge distribution. From the equation only you can say, see, phi is directly proportional to charge and inversely proportional to the nature of the medium. It is not dependent on anywhere the geometry of the figure comes, no. Area is not included. So it is not dependent on Gaussian surface. The second point is what? It is not dependent on the charge distribution. It simply says the net total charge enclosed. It is not talking about what? In which way you have distributed the charge. So it is charge distribution, it is not dependent on. Then the state of rest or of motion. The state of rest or motion of the charges. Next, the presence of charges. This is very, very important. The presence of charges outside the surface. So what does it mean, the presence of charges outside the surface? It's very simple. What is the Gauss law? Total electric flux over a closed surface is given by the formula 1 by is equal to 1 by epsilon naught times the total charge enclosed. So it is talking about enclosed charges. So if I consider the Q1, Q2, Q3, Q4, Q5 and the given Gaussian surface is this one. Okay, let me draw it in different way. So now tell me, what are all the charges that contributes to the net flux of this process? If this Gaussian surface, for this Gaussian surface. According to Gauss law, phi is given by Q enclosed by epsilon naught. Correct? So what are all the charges that contributes? That is enclosed in the Gaussian surface. This is our Gaussian surface. So what are all the charges present inside the Gaussian surface? Q1 plus Q4 plus Q5 with the sign divided by epsilon. Can I include Q2 and Q3? You cannot include because it is not there in the Gaussian surface. Clear or not? Everyone?
Yes, ma'am.
Outside charges has no contribution to the net electric flux of this Gaussian surface. That is the closed surface in consideration. If it is clear,